Hello, my name is Karen, and I'm going to give you a quick guide to our Redox microelectrodes, also called ORP microelectrodes. This introduction will focus on the most important measuring characteristics of Redox electrodes. If you would like in-depth information and details about Redox electrodes, please see the lecture about Unisense potentiometric electrodes. This is a couple of photos of Unisense Redox microelectrodes. We make them with different cables and connectors so they can be applied both in the lab and in the field, including shallow and deep sea applications. Unisense Redox electrodes are made for research and experimental applications where small electrode is needed. The electrodes work principally like larger Redox electrodes. Our electrodes are just smaller and can therefore be used for non-destructive measurements in natural samples or for measurements in small volumes. These schematic drawings illustrate how the electrode works. This schematic drawing shows the tip, which consists of a thin platinum wire, which is etched down to the desired tip diameter and covered with insulating glass. So only a few micrometers of platinum wire is exposed at the tip. This section of the electrode tip illustrates the measuring principles at the platinum surface when measuring in a sample. The sample contains substances which can exist in different oxidation states. The oxidized and the reduced form of the substance is normally referred to as a redox couple. The catalytically active platinum surface facilitates the redox reactions, and at equilibrium, no net changes in the oxidation state of the redox couple takes place. If the redox electrode is coupled to a reference electrode placed in the same solution, connected to a high impedance millivolt meter, like a Unisense uniamp meter, the potential measured is proportional to the average oxidation state of the redox couples found in the sample. In other words, the redox potential. The impedance of the millivolt meter determines how much current flows from redox electrode to the reference electrode. A standard non-high impedance millivolt meter can therefore not be used for microelectrodes because it practically depolarizes the electrode. Due to the small tip area of the redox electrode has a very high impedance, and therefore, to keep the measured potential stable, the input impedance of the millivolt meter must be significantly higher than the electrode impedance. We recommend at least 10 to the 13th ohm. Only millivolt meters of the highest quality live up to that, and we only guarantee the redox electrode specifications when using a Unisense millivolt meter. Detailed specifications are available on our website. I will, however, elaborate on a few of the most important sensor specifications. Unisense microelectrodes are handmade, and our skilled technicians can customize sensors to obtain the best possible characteristics and design to your specific application. The model name indicates the tip size of the electrode, thus an RD50 have a tip diameter of 50 micrometer. We produce them with standard tip diameters from 10 to 500 micrometers, but can customize them to any tip diameter up to 800 micrometers. Besides the tip size, we can customize the design of the tip to be more or less slender, as well as the body length and shape. See our tip selection guide to get more information about which tip size to choose for your application. The detection limit will be strongly influenced by the experimental design. The detection limit of 0.1 millivolt is the same for all of our electrodes. A redox microelectrode responds fast to changes in redox potential. Typically, they have a response time less than 10 seconds, but this will also depend on the presence of redox couples in the sample. We can modify and adapt our redox electrodes in many ways, making them useful for a broad range of applications. We can build them into needles to protect the glass casing from getting damaged. The needle electrodes can be produced with different needle diameters and length. See our homepage for details regarding this. The most robust needle version is the RDNP, which is this one, and it's made for penetrating membranes of closed incubations. For measurements in small test tubes, we produce a combination electrode, RD500C, where a microreference electrode is built together with a RD500. So the combination electrodes is both a redox and reference electrode built together. With a protection cap, the electrodes can be safely used for bulk measurements in larger samples. The electrode body can also be made of steel with threads, so it can be screwed into pipe systems or incubators. For the microrespiration system, the electrode is built into this special guide and has a long slender tip, so it can easily be inserted into small microrespiration chambers. For use in closed flow systems, we can build the electrodes into different gas-tight flow cells, ranging from transparent glass flow cells to pressure-tolerant steel swage-like flow cells and peak flow cells. Redox electrode built into flow cells must be used with a Unisense reference electrode, also built into a flow cell, mounted in the same flow system to make sure there's liquid contact between the reference electrode and the redox electrodes. In general, if you have any special requests regarding adaptations, please do not hesitate to contact us. Thank you for watching this Unisense microsensor lecture. I hope you enjoyed it. If you have any questions, you're more than welcome to contact us at sales@unisense.com.